In this video, I'm going to talk about how we can use static routing for load balancing and also for fault tolerance or redundancy. I want first to talk about the load balancing, and after that we can talk about the fault tolerance and learning more about static routing features. Look at this scenario. In this scenario, we have two routers, router 1 and router 2. And also we have two paths between the router 1 and router 2. First, I want to configure two static routes between the R1 and R2 and show to you how we can use static routing for load balancing traffic between these two links. Let me to first configure this scenario. For example, we should start with the R1. In R1, this is the configuration of R1 conf d, then host name is R1, so easy. Interface serial 10, we have two interface serial 10, the IP, or for example, let me to start from ETH00, and then interface ETH00, this interface has one IP address, IPv4 address, IP address 10.1.0.1.255, then 255.255.0, and after that no shutdown. That's it. Let's to copy this configuration for other interfaces, ETH01 serial 10 and also serial 11. ETH01, this is the serial 10, and finally serial 11. Now for ETH01, I want to use 10.1.1.1 for IP address, for IP addressing. And then in serial 10, we can use 10.1.2.1. Look at here, 10.1.2.1. And for the serial 11, I want to use 10.2.1.1. 10.2.1.1. That's it. This is the configuration of R1. And after that, we can copy this configuration and changing some of them for router 2. This is the router 2's configuration. In router 2, we have only ETH00. We don't have ETH01. And also we have serial 10 and serial 11. ETH00's IP address is 10.2.0.2. And after that, serial 0's IP address is 10.1.2.2. And serial 10 has 10.1.2.2 as its IP address. And serial 11, 10.2.1.2. That's it. Also, we have three PC, VPC1, VPC2, and also server 1, VPC1. Okay, this is the configuration of VPC1. IP of VPC1 is 10.1, okay, 0.10 with mask of 24, and 10.1.0.1 as an IP, as IP address of gateway. It's gateway, the ETH00 of R1. Then we should copy this configuration for VPC2 and also for the server. VPC2 server 1. VPC2's IP address is 10.1.1.10 and the gateway is 10.1.1.1. The server 1's IP address is 10.2.0.10 and the gateway IP address is 10.2.0.2. That's it. Let me to copy this configuration in R1, R2, and also PCs. Here is our configuration. Okay, this is the CLI of router 1, copying the configuration of router 1, and after that we should go to the router 2's configuration, copy the configuration, and then paste in the router 2's CLI. We should change the host name. Host name is R2. Okay, let me change in the notepad file, and after that the VPC1, saving the copy the configuration and pasting in the VPC1. Then let me go to VPC2. This is the VPC2's CLI, and then here we should copy it here. And after that, for the server 1, this is the server 1, and here I want to copy the configuration of server 1. Now we did all of the initial configuration. Now we should check the routing tables of R1 first. Show IP route. In routing table of R1, we can see 4 connected networks, 1, 2, 3, 4, because we have 4 links, 10.1.0.0, 10.1.1.0, 10.1.2.0, and also 10.2.1.0. So easy. And let me check to R2's routing table. Show IP route in R2. 10.1.2, 10.2.0.0, and 10.2.1. Look at here, 10.2.0.0, 10.1.2, and 10.2.1. 1. Now I want to configure a static routing for load balancing. Load balancing means I need to use both of these links to forward traffic between router 1 and router 2. It's so easy to configuration. You should do same things 2 times. Look at here. For example, in R1, I can use the outgoing interface next stop or outgoing and next stop. I want to use the third method, the most complete method. IP route for 10.2.0.255.255.255.0 with the outgoing interface of serial 10 and the next stop of 10.1.2.2. 10.1.2.2 is the IP address of the serial 10 of R2. That's it, the first static route. And the second IP route again for 10.2.0.255.255.255.0 with serial 11. Okay, and then the next stop is 10.2.1.2. Okay, the IP address of the serial 11 of the router 2. So easy. I configure 2 static route for the same network, but with 2 paths. Let me check the routing table. Do show IP route in R1. Do show IP route in R1 shows us that we have 2 static route. Because I configure this static route for 1 network, here we can see a blank space. This means that we configure 2 paths for 1 network. Okay, as you can see, 2 paths now is available. So easy. And then in R2 we have, as you see, 2 paths for reaching the 10.1.0.0 and also 2 paths for reaching the 10.1.1.0. Because of that, we should configure for both of these networks 2 paths. For example, I can configure IP route for 10.1.0.0 with the mask of 255.255.255.0 and using the serial 10 with the 10.1.2.1 as next stop, and then again for this network serial 11 with the next stop of 10.2.1.1. Okay, 10.2.1.1. And now I configure 2 paths for this network. Again, I should configure 2 paths for the 10.1.1.0. Let me to configure the first path from serial 10 for 10.1.1.0, and the second path, as you can see, is for the 10.1.1.0 and from the serial 11. Now, if you check the routing table of router 2, show IP route. Here we have show IP route static. You can see that we have 4 static routes. 2 of them for the 10.1.0.0 and 2 of them for the 10.1.1.0. And now we have load balancing between these 2 routers. Why? Look at here. If for example, VPC1 sends the traffic to server 1, maybe this traffic forward from the serial 10 and maybe this traffic forwarded from the 10.2.1.0. Okay, this means that some traffic can go from the upper link to the R2, and some traffic can forward from the lower link. This means load balancing or load sharing. Okay, let me to show you. For example, in VPC1 we can use trace route command. Please trace can show us the path. Please trace the path to the 10.2, the IP address of the server 1, from VPC1 to server 1, 10.2.0.10. Okay, let me check. The traffic first went to the 10.1.0.1, and then the traffic sent to the 10.2.1.2. 10.2.1.2 is the serial, this is the lower link. The first traffic sent from the lower link. Okay, or for example, assume that I use VPC2 for trace again 10.2.0, for example 10 here. As you can see, the traffic from VPC2 again sent from the lower link. This is random. Maybe some traffic goes from the upper and some traffic from the lower link. The reason or the mechanism of load balancing is beyond of the scope of this video, but the mechanism of load balancing can per destination or can be configured to per packet. The default is per destination. This means that for same destination, the traffic should go from one link. For example, as you saw, for the destination of server 1, VPC1 and VPC2's traffic is sent from R1 lower link. Okay, we can check, for example, the connectivity between VPC1 and VPC2 with the ETH00's IP address. Look at here in VPC1, please trace 10 to